These medications have a dirty little secret that nobody's going to tell you. So these things are being called like some kind of miracle because it seems like when you take it, you lose weight and you get healthier. First one is that these actually increase nausea. The way that they reduce your appetite is by making you sick to your stomach.
The primary way that these medications decrease your appetite is by binding to receptors within your brain that stimulate sensations of satiety, as well as inhibiting neurons that would stimulate your appetite. These medications also alter the synthesis of things like dopamine and glutamate, which decreases food cravings, and the anticipatory response to food that drives many people to overconsume. The reason these medications may cause a degree of nausea is because they do indeed slow down and delay gastric emptying, yet another way that they reduce appetite, because humans don't want to put more food in their stomach when there is already food inside of it. However, when this is excessive and if the dose is not titrated properly, this could induce a degree of nausea, but that is not their primary mechanism of action to decrease one's appetite.
Mechanism, and this is the really crazy part, is that these things actually increase the number of fat cells that your body has.
This appears to be true when you add glucagon-like peptide 1 agonists into a test tube. And it's probably true in humans, but let me tell you why this is a good thing. Fat tissue can expand via hypertrophy, or the growing of pre-existing fat cells, or hyperplasia via making more fat cells. As you can see, the amount of fat contained in these fat cells and these fat cells is the same. The only difference is how many fat cells contain this fat. An important caveat is having more fat cells doesn't necessarily mean you're going to just magically put on more fat. For example, if you eat in a surplus of 10,000 calories, whether you have 25 billion large fat cells or 20 billion small fat cells, you will still lay down the same amount of adipose tissue mass. However, to say it simply, large fat cells kinda stink. When a fat cell begins to enlarge, it becomes more unhealthy and begins to produce more pro-inflammatory molecules, becomes more insulin resistant, and begins leaking fatty acids. When fat cells can't accommodate any more fatty acids, these fatty acids begin getting stored in places like the liver, muscles, kidney, and other organs. This is known as lipotoxicity or ectopic lipid, and this leads to things such as fatty liver, improper muscle functioning, as well as increase the risk of atherosclerosis and cardiometabolic complications, as adipose tissue is the safe place to store fat, and places like the organs and the skeletal muscle are backup reserves when our adipose tissue cells have become so enlarged they cannot accommodate any more fat, because we do not have enough adipose cells. Adipose tissue hypertrophy is correlated with adipose tissue inflammation, fibrosis of adipose tissue, hypoxia, which is a lack of oxygen to adipose tissue, and poor metabolic health. However, hyperplastic fat tissue, which grows via hyperplasia, does not provoke these pathological and unfavorable metabolic changes. Therefore, it appears that the ability of GLP-1 agonists to increase the number of fat cells that we have can help to enhance whole body insulin sensitivity, decrease the storage of fat within very sensitive organs such as the liver, muscles, and heart, and is even hypothesized to reduce weight gain by improving whole body metabolic function. Therefore, although it may sound scary, by increasing the number of fat cells we have, these GLP-1 agonists may improve the health span and lifespan of those with excess adipose tissue by decreasing its unfavorable effects on this individual's entire body.